Hello students, welcome back. I hope you all are doing fantastic out there, isn't it? So we are doing logarithms from ICSE book of class 9 and we have already completed till exercise 8C in our previous videos. So today we are going to start exercise 8D right from question number 1. Okay, so let's begin. This is exercise 8D question number 1. If 3 upon 2 log A plus 2 upon 3 log B minus 1 equals to 0. This is the given equation. Find the value of a to the power 9 times b to the power 4. So we are asked to find the value of a to the power 9 times b to the power 4. Okay, so let us do this. First question from exercise 8D. So let us first copy the given equation. Okay, 3 upon 2 log a plus 2 upon 3 log b minus 1 equals to 0. This is the given equation, isn't it? So now what we do is we take this number as power. Okay, we can do this, isn't it? If a log m, then this a can be taken as power log m to the power a, isn't it? This is the rule of logarithm. So we can write this as log a to the power 3 upon 2 plus this number 2 upon 3 we take as power, so log b to the power 2 upon 3 equals to minus 1 we take to the right hand side, becomes plus 1. Okay, now we have log a plus log b, isn't it? So log a plus log b is log a into b, isn't it? So log a into b, a is a to the power 3 upon 2 into b is b to the power 2 upon 3, isn't it? Log a plus log b is log a into b equals to 1. So base is not mentioned here, isn't it? So we can assume the base of this logarithm is 10. Okay, log a to the power 3 upon 2 into b to the power 2 upon 3 to the base 10 equals to 1, isn't it? So let us convert this logarithmic equation to exponential form. Okay, so we can write this as 10 is base, isn't it? This 10 remains here as base, this 1 comes here as power, equals to, this goes to the right hand side, isn't it? A to the power 3 upon 2 into b to the power 2 upon 3. Okay, now since we need 9 and 4, isn't it? So 3 into 3 gives us 9, isn't it? And 2 into 2 gives us 4. That means, or we multiply by 10 to the power 6. Okay, a to the power 3 upon 2 into b to the power 2 upon 3 whole to the power 6. I am putting power 6 to the both sides of this equation. Okay, we can do, isn't it? We can square both sides, we can cube both sides. Okay, so we can put power 6 both sides, power 6. Okay, so this 1 power 10 to the power 1 means 10. I am putting power 6 here in the left hand side and in the right hand side as well. So let me write this here. Okay, now this power 6 is for both the numbers a and b, isn't it? So a has power 3 upon 2 already into 6 times b to the power 2 upon 3 into this power 6. This power 6 is for both a and b. Okay, so I put the power individually into 6 equals to 10 to the power 6. Now let me continue here. So 2 1s are 2, 2 3s are 6, isn't it? So 3 1s are 3, 3 2s are 6, isn't it? Now we have a to the power 3 into 3. This 3 is in the numerator, so we should multiply. A to the power 3 into 3 is a to the power 9. A to the power 9 into b to the power 2 into 2 is 4. B to the power 4 equals to, in the right hand side we have 10 to the power 6. 10 to the power 6, isn't it? So we were asked to find the value of a to the power 9 times b to the power 4. So we found a to the power 9 times b to the power 4 equals to 10 to the power 6. So this is the answer for question number 1 of exercise 8D. Okay, I hope you got this. Now let us move on to the next question. Let us do question number 2. If x equals to 1 plus log 2 minus log 5, y equals to 2 log 3, and z equals to log a minus log 5. Find the value of a if x plus y equals to 2z. Okay, so these are the given conditions. X equals to this, y equals to this, and z equals to this. And this is also a given condition. So we are asked to find the value of a from this equation. Okay, so let's begin. Let us first write the given equation. Since x plus y equals to 2z, this is the given equation. So now we put the values of x, y, and z. Okay, what is x? X is 1 plus log 2 minus log 5. So instead of x, 1 plus log 2 minus log 5, isn't it? Plus y. What is y? 2 log 3. Instead of y, I write 2 log 3 equals to, we have 2z, isn't it? So we write 2 here as it is. Z means log a minus log 5. So instead of that, log a minus log 5. Okay, this is 2, this is z. Okay, 2z. Now 1 means log 10 to the base 10. So bases are not given, means we should assume the base is 10, isn't it? So 1 means you can write log 10. Log 10 to the base 10 is 1 plus log 2 minus log 5 plus, okay, plus 2 log 3 means log 3 squared, isn't it? This 2 goes to the power. 2 log 3 means log 3 squared. So log 3 squared is log 3 squared means log 9, isn't it? Equals to 2 into log a, 2 log a minus 2 into log 5, 2 log 5. So let us bring log 5, 2 log 5 to the left hand side and keep this log 2 log a in the right hand side. Okay, now we have log 10 plus log 2, okay, plus, let me write this positive number first and write this letter. Okay, log 9 plus log 9, log 10, log 2, log 9. This minus 2 log 5 comes to the left hand side and becomes positive. Log 2 log 5 means log 5 squared. 5 squared means 25. Log 5 squared, isn't it? 2 log 5 means log 5 squared. So 5 5s are 25. You can write log 25 straight away. Log 25. Now we should not forget this, minus log 5 minus log 5. Okay, log 10, log 2, log 9, log 25, and this minus log 5 is here. Now we have in the right hand side equals to 2 log a means log a squared. This 2 goes to the power. Now what we do? Log a plus log b plus log c plus log d, isn't it? We know that if log a plus log b plus log c, then we can write this as log a into b into c, isn't it? In the similar manner, log a plus log b plus log c plus log d means log a into b into c into d. Okay, and minus log 5 equals to log a square. Now we know that log a minus log b can be written as log a upon b. If there is minus sign in between two logarithms, log a minus log b, then we can write as log a upon b. We must be sure that the bases are same. Okay, here the bases are not mentioned, means bases are 10. Okay, if the bases are different, we can write like this. So, or log m minus log n, or log a minus log b. 5 is b, this is a. Okay, this means log 10 into 2 into 9 into 25, 10 into 2 into 9 into 25, 10 into 2 into 9 into 25, divided by 5, minus, isn't it? So comes in the denominator, equals to log a square. Now we can leave log and log from both the sides. Okay, this log and this log is left. Now 5 ones are 5, 5 5s are 25. Log and log we leave, so a square I write in the left hand side. Okay, a square equals to, in the right hand side we have 10, this goes to the right hand side, isn't it? So 10 into 2 into 9 into 5 divided by 1. Every number has 1 in the denominator, so we need not write that. So let me continue the sum here. This gives us a square, isn't it? So we take this square to the right hand side. Okay, this square to the right hand side. A equals to we are asked to find a, isn't it? Root under 10 into 2 into 9 into 5. This means a equals to root under 10 means 2 into 5, 10. 2 5s are 10 into this 2 into 9 means 3 into 3 into 5. Okay, into 5. This 10 is 2 into 5, this 2 comes here, 9 means 3 into 3, this 5 comes here. Okay, so a equals to this 2 and this 2 we make pair and free from the root. Okay, into this 5 and this 5 we make pair and free from root. This 3 and 3 we make pair and free from root 3. So a equals to 2 5s are 10, 10 3s are 30. The value of a is 30. Okay, so we were asked to find the value of a, and the value of a is 30. I hope you got this. Now let us move on to the next question. Okay, now let us do question number 3 from exercise 8D. If x equals to log 0.6, y equals to log 1.25 and z equals to log 3 minus 2 log 2. Find the values of x plus y minus z. Okay, we are asked to find the values of x plus y minus z. Given conditions are x equals to this, y equals to this, and z equals to this. So let us do this. So since we are asked to find the values of x plus y minus z, so this gives us, what is x? X means log 0.6. The value of x is log 0.6. Log 0.6 plus y. So plus, what is y? Y is log 1.25. Log 1.25 minus, and what is z? Z is log 3 minus 2 log 2, isn't it? So let me put a bracket. Okay, log 3 minus 2 log 2. Now log 0.6 we copy as it is, log 0.6 plus log 1.25 minus into plus is minus, log 3 minus into minus is plus. Okay, log 3 minus into plus is minus, log 3 minus into minus is plus, minus into minus is plus. 2 log 2 means log 2 squared. This 2 goes to the power 2 squared. Okay, so 2 squared means 4. Let me write 4 straight away. 2 squared means 4. Okay, so now we have this and this are positive and this is negative, isn't it? Which means log 0.6 into 1.25 into 4, isn't it? So we multiply all the positive numbers and divided by the negative goes to the denominator. Minus log 3 means 3. Now we have log 3 1s are 3, 3 2s are 6. So 0.6 means 0.2. So 4 2s are 8. Log 0.8, 4 2s are 8, isn't it? 0.8 into 1.25. 1.25. This means log 8 5s are 40, 0, 4 in hand, 8 2s are 16, plus 4, 20, 0, 2 in hand, 8 1s are 8, plus 2 is 10. Okay, so we put a decimal point before 3 digit, 1, 2 and 3. There is a decimal point before 3 digits, isn't it? So 1, 2 and 3. We put a decimal point here, which means the zeros have no values after decimal point. So we can write this as log 1 to the base 10. No base means base is 10, isn't it? So log 1 to any base is always 0, isn't it? So this is the answer. Log 1 to any base is always 0. Okay, so log 1 to base 10 is 0. So this is question number 1. We are asked to find the values of x plus y minus z. X plus y minus z is 0. And question number 2 is question number 2 of the same number. Okay, number 2 is we are asked to find 5 to the power x plus y minus z. 5 to the power x plus y minus z, isn't it? This is question number 2. So this equals to 5, we write here as it is. So x plus y minus z, x plus y minus z is 0. We found 0, so we put 0 here. X plus y minus z is 0, isn't it? So 5 to the power 0 is 1. Any number raised to power 0 is 1. Okay, any number raised to power 0 is 1. 1 to the power 0, 1. 5 to the power 0, 1. X to the power 0, 1. But please remember, 0 to the power 0 not equal to 1. 0 to the power 0 is undefined. Other than this case, any number raised to power 0 is always 1. So 5 to the power 0 is 1. I hope you got this. Now let us move on to the next question. Okay, now let us do question number 4. If a square equals to log x, b cube equals to log y, and 3a square minus 2b cube equals to 6 log z. These are the given conditions. We are asked to express y in terms of x and z. Okay, which means we are asked to find y in terms of x and z. So let us write these given conditions. Since a square equals to log x, but we need 3a square, isn't it? 3a square. We have only a square. So let us multiply both sides of this equation by 3, or 3a square equals to 3 log x. So this is equation 1. Okay, 3a square equals to 3 log x. I multiplied both sides of this equation by 3. Now we have another equation, and b cube equals to log y, but we need 2b cube, isn't it? So multiplying both sides of this equation by 2. So 2b cube equals to 2 log y. This is equation 2. 2b cube equals to 2 log y. Okay, now let us use this equation. Since we have 3a square minus 2b cube minus 2b cube equals to 6 log z, isn't it? So let us put the values of 3a square and 2b cube. Or what is 3a square? 3a square is 3 log x. 3 log x. 3a square is 3 log x, isn't it? 3 log x minus 2b cube. 2b cube is 2 log y. 2 log y. 2b cube means 2 log y, isn't it? 2b cube means 2 log y. So minus minus 2b cube 2 log y. Okay, equals to 6 log z. 6 log z. Or let me take this y to the right hand side and bring this z to the left hand side, because we are asked to express y in terms of x and z, isn't it? So 3 log x means log x, 3 goes to the power cube. So 6 log z comes to the left hand side and becomes minus. So 6 log z means log z to the power, this 6 goes to the power 6, equals to 2 log y, minus 2 log y goes to the right hand side and becomes plus. Okay, log y, 2 log y means log y square, log y square. Okay, so we have log x cube minus log z to the power 6, isn't it? This means log m by n, isn't it? Log m minus log n means log m by n, x cube by z to the power 6 equals to log y square. Now we leave log from both the sides. Okay, we should not cancel log. Okay, log cannot be cancelled. We can leave log from both the sides. So y square equals to, so y square we bring here in the left hand side, y square equals to, this number goes to the right hand side, x cube by z to the power 6. So let me continue here. So y square when goes to the right hand side becomes root, isn't it? So or y equals to, square goes to the right hand side and becomes root under x to the cube, x cube upon z to the power 6, z to the power 6. This root is for both the numbers, numerator and denominator. Okay, so y equals to, root means x to the power 3 is already there, root means into 1 by 2 divided by z to the power 6 into 1 by 2, isn't it? Root means 1 by 2. So this root is for both numerator and denominator. So 1 by 2 for both numerator and denominator. Okay, or y equals to 3 into 1 is x to the power 3 by 2, 3 ones are 3 upon 2 upon z, 2 ones are 2, 2 3s are 6, isn't it? So z cube, 2 ones are 2, 2 3s are 6. Therefore y equals to x to the power 3 by 2, 3 by 2 divided by z cube. Okay, so this is the value of y in terms of x and z. I hope you got this. Now let us move on to the next question. Let us do question number 5. If log a minus b upon 2 equals to 1 upon 2 log a plus log b. So this is the given equation. Okay, so we are asked to prove a square plus b square equals to 6ab. So let us do this. Let us first write the given equation. Since log a minus b upon 2 equals to 1 upon 2 log a plus log b, isn't it? 1 upon 2 log a plus log b. So this is the given equation. Or what we can do is log a minus b upon 2 equals to 1 upon 2 log a plus log b means log a into b. A into b is ab, isn't it? Log a plus log b is log a into b, ab, log ab, isn't it? So log a minus b upon 2 equals to this 1 upon 2 we raise to the power. Okay, log ab to the power 1 upon 2, this goes to power. Okay, now we leave log from both the sides, or a minus b upon 2 equals to ab raised to power 1 by 2. Power 1 by 2 means root, isn't it? Power 1 by 2 means root. If we bring this to the left hand side, becomes a square. Or a minus b upon 2 whole square equals to ab. Okay, this 1 by 2 when brought to the left hand side becomes a square equals to ab. Now a minus b whole square, a minus b whole square upon 2 square is 4 equals to ab. Okay, so let me continue this. This square is for both the numbers, numerator and denominator. So a minus b whole square, so 2 squared is 4. Now we cross multiply. 4 into AB is 4AB, or A minus B whole square equals to 4 into AB is 4AB. 4AB. Okay, so A minus B whole square means A square minus 2AB plus B square. A minus B whole square means A square minus 2AB plus B square equals to 4AB, or A square plus B square we keep in the left hand side plus B square equals to minus 2AB we take to the right hand side. So 4AB is already in the right hand side, minus 2AB goes to the right hand side and becomes plus 2AB. This is AB, okay, minus 2AB goes to the right hand side and becomes plus 2AB, or A square plus B square equals to 4AB plus 2AB is 6AB, isn't it? So this is what we were asked to prove. A square plus B square equals to 6AB. So A square plus B square equals to 6AB. Hence proved. Hence proved. Okay. Okay, I hope we got this. Okay, this was for today. Thank you so much. Stay connected. I'll upload the remaining questions in the next video. Okay.